Hi, Princeton. All right, so in this video, I'm going to go through how to use the guided notes to help you in preparation for writing your essay. So in these boxes, we're going to fill in the good things and the bad things about levees and canals. In the first video, we already learned some key information about levees that can get us started on filling these in. So under pros, why are levees important? Levees are good because they can protect us or protect cities from flooding. But we also learned that they're bad because they are one of the causes of wetland loss. They cause wetland loss. Under canals, what's something good about canals? Canals allow for transportation to oil and gas rigs. But what's bad about them? They also cause wetland loss. And then think about why this is bad, because wetlands are really important for the coast. They're also important for Louisiana's ecosystem, and a lot more reasons which we'll read about now. So as we read these articles, you're going to fill in your guided notes. For the rest of this video, I'm just going to be reading through the articles. I'll model annotation for the first one, but for the rest of it, I'm just going to be reading out loud. So if you feel like you do not need these articles read out loud or would not like to listen to these articles be read out loud, you are welcome to turn off this video, read these articles on your own, and then write your own essay. But remember, as I said in the last video, these essays need to be done by the end of class. Whatever does not get finished during class will be your homework, and I'll have Ms. Dargan create a list of the people who did not write their essays during class, so I know who to check for essays on Monday. All right, so let's read through these articles together. The first article is about levees. Levees can be either natural or man-made. Man-made levees are embankments that are built to keep water in. They are built by rivers to keep them from overflowing from their banks. If we're looking for pros about levees, that's a good pro. We could underline that line right there. They are made from less impermeable soil, such as clay, and are narrow at the top but wider at the base. They can range in height because there is no set height on how tall they can be. There are many advantages to levees. This word advantages tells me that we're going to be reading about the pros, so I'll underline that so that I'm keeping an eye out for the pros. They allow people to live by rivers or oceans without the fear of flooding, unless the levee breaks. They also provide protection. In the Netherlands, the advantage of using a levee is that it has stopped the ocean waters from flowing onto the land. This has allowed the land to be occupied by people. Levees also keep lakes at bay and rivers from overflowing their banks. All of this paragraph is a really good example of the pros of levees. So you can take this time, pause the video, and add some of those pros in your guided notes up in the column where it says pros about levees. Last paragraph, levees come with many disadvantages. So underline that word as well. That tells us that we're going to be talking about the cons, the bad things about levees. While providing protection from flooding in one place, levees can divert water elsewhere, causing flooding in another place. Crops can drown and be killed in the flood, causing problems for farmers. Levees can also fail. They can fail by overtopping, underflow, slumping, or erosion. Overtopping is when water rises above the levee. Underflow is when water permeates the sand deposits underneath the levee and water rises up on the other side. When the weight of the water is too heavy for the levee, it can push over the sides. This is called slumping. Erosion is when the sides and the top of the levee slowly start to wear down due to the waves of the water. All of these are good disadvantages for levees or cons for levees. All right, for the rest of this, I'm not going to be modeling annotation or talking about pros and cons. I will just be reading out loud. So Article 2, Levees and Canals. Since the 1930s, Louisiana has lost nearly 1,900 square miles of land, an area roughly equivalent to the size of Delaware, to the size of the state of Delaware. Many factors have led to the delta's collapse. One of the most significant is that the lower Mississippi River has been straitjacketed with huge levees as part of a national program to control the Mississippi River and protect communities, economic infrastructure, and croplands from river flooding. But the delta's wetlands are built and sustained by sediment delivered by the river. Cutting the river off from its delta with levees doomed existing wetlands and largely stopped the cycle of new wetlands growth. Without land building deposits from the river, the delta is doomed to continue sinking beneath the water, endangering people, wildlife, and jobs. Exacerbating the problem are vast networks of shipping canals, including the Mississippi River Gulf Outlet, the Huma National Navigational Canal, and the Freshwater Bayou Canal. Thousands of miles of oil and gas canals have been dug to accommodate every infrastructure and extraction. These channels and canals alter the natural hydrology and allow saltwater to penetrate deep into the wetlands, disrupting the salinity balance and killing the vegetation of freshwater wetlands, causing them to subside underwater. In addition to these land loss issues, the Delta has in recent years suffered through additional catastrophes. In 2005, Hurricane Katrina and Rita wrecked the coastal communities. The damage they wrought in the form of flooding and storm surge was made worse by the previous loss of miles of protected wetlands. Then in 2010, devastation came again in the form of the BP oil disaster, where millions of barrels of oil spewed from the Deepwater Horizon oil rig only to wash up on Louisiana's shorelines. Both of these catastrophes were crushing blows to an already degraded region. Their effects and increased urgency to the need for long-term, large-scale restoration of the Mississippi River Delta. Article 3, Anti-Canals. For decades, researchers have been documenting the relationship between canal dredging and the state's loss of almost 2,000 square miles of coastal wetlands. The State Coastal Protection and Restoration Authority, using research from the U.S. Geological Survey, says almost 10,000 miles of canals have been dredged for oil and gas. Many researchers believe the figure is considerably higher because the agency's numbers rely mostly on permits, and there wasn't a reliable permitting system until the passage of the Federal Clean Water Act in 1972. Canals have been singled out as the primary villain of land loss because their impacts hit several layers of the wetlands ecosystem. Gene Turner, Louisiana State University's Distinguished Research Master and Shell Endowed Chair in Oceanography and Wetland Studies, has been quantifying canal impacts for decades. You have the direct loss of marsh caused when you dredge these canals, converting wetlands to open water, said Turner, who has reported that the average oil field canal is 12 feet deep and more than 50 feet wide. But when they took the material they dredged to dig the canals and deposited on the bank, creating a spoil levee about 8 to 12 feet high and 15 feet wide or wider. That's more direct loss. Turner said his studies show the direct loss of wetlands from the canals and their spoil banks comes to 60% of the 20,000 square miles lost since the 1930s. However, the indirect impacts of the canals resulted in an even larger area of wetlands being converted to open water, Turner and other researchers have reported. Turner and other scientists estimate that 35 to 42% of the state's catastrophic land loss could be traced to oil and gas canals. He said a more recent analysis of land loss in the Barataria Basin, soon to be published, placed that figures at a close to 85%. Some of the numbers I have placed it as high as 90% overall, he said, but whether it's 30, 45, or 80%, there's a clear relationship between the number of canals in the area and the amount of land loss. That relationship is undeniable. Alright, that's the last article I'm going to read. You can read Article 5 independently. Once you're done, if you'd like to do more research, there are search terms on the last page. You can try typing these into Google. They might pull up more information. You can also go to the science website and use that interactive link. That was the one that I've used in the last video, which looks like this. Mine is not letting me switch tabs. So it looks like this. So if you'd like to do that, you can, or you can just start writing your essay. Make sure you filled in your guided notes, and I'm going to be having Ms. Dargan check for who's completed their essays. If you haven't completed your essay, that is your homework. It is actually in your homework packet as well. All right, good luck with your essays, and let Ms. Dargan know if you have any questions.